I'm glad to be here. And yeah, surprise, surprise, we're going to continue the narrative of the day and talk about microservices. I'm Boyan Dimitrov. I'm the platform automation lead at Hailo. And today we're going to start by basically showing you what we've built. But before that also, what problems we had. Why did we move to microservices at all? And we're going to wrap up by saying how we do testing in production, how you actually deliver business value when you're in this microservices world. To start off, let's introduce what we do. We're effectively a taxi app company. We work with licensed taxi fleets across the world, and we aim to provide the best localized user experience. And to do that, we built a lot of services for individuals, for businesses, for the drivers themselves, making their lives easier. We started in London, and we've started growing and expanding in Europe, in Asia. We have over 60,000 drivers. We have millions of passengers. And yeah, it's been quite an interesting ride. Back in 2011, when the company was founded, we started very, very simple. We had basically PHP API, Java backend, both built as monolithic applications on top of AWS. And yeah, it was pretty simple system to reason about, pretty simple system to operate. It was the simplicity which actually allowed us to iterate on the product and get something out there which basically gets traction. And yeah, from then on, the business starts expanding, good problems to have. However, in those early days, we also did we incurred some technical debt. And it was this technical debt that presented some challenges as we started scaling the business. As every company, as we started expanding to more and more countries, we tried to get more people on board, aiming to deliver more features out the door. Unfortunately for us, this didn't work, and we found the hard way that extending monoliths is a very hard challenge. We were adding more people into our development teams, but our release cycles were basically slowing down and slowing down and slowing down. We were failing to add business value as quickly as we wanted. And on top of that, we also had a lot of operational problems. Because we were replicating our monolithic stack in every city we go to, so you think like we go to Dublin, we'll be building designated servers for that. Our uptime was constantly going down. And the reason was, well, so many monolithic applications built in a very data center-like way, hot standbys, 30-page documents about how you fail over those things, 30 people on a bridge 3 a.m. in the morning trying to figure out why something broke down and, yeah, how to even fix it or who is responsible for fixing it. We had all those problems, and yeah, it wasn't a great place to be. So for us, it was clear that it's time for a change, and what we did was we identified several areas of improvement. Obviously, on the technical side, we actually wanted to start building things on the cloud the right way, automate every workflow, every action. We wanted to be resilient, and so we wanted to build self-healing components that don't wake up us at night, just notify us when, well, like, what happened and how they fix themselves, if possible. And we also wanted to move to a more service-oriented architecture. We wanted to deliver more things in parallel, and basically having people step on each other's toes, trying to bolt logic on top of like big monoliths was not the way to go. We didn't want to stop there. We knew that if we're going to do this, we have to basically go a bit further and make an organizational change, basically adopt a more DevOps mindset across, because you have to, like, if you're going for the big challenge, you have to empower your developers. You have to give them the responsibility and the opportunity to do the right thing and be more involved in how you build and spec products out. So with all those things in mind, back in 2013, we kicked off a project that was supposed to get us there. And the aim of this project was to basically build a new platform and migrate everything that we had without any downtime as we go. We didn't do it just lift, shift, done. We did it in pieces, and it took about 2 years to execute and to end. I think last week, we finally migrated the last piece of code which was left out from our stack, which was great success. Nowadays, we have a microservices ecosystem which is pretty much 99% written in Go. It's like we decided that Go is a better language, fits better what we want to achieve on the cloud. And yeah, we migrated our PHP and Java stack to that. Each component that we chose for this platform, being infrastructure, being middleware, being whatever you like, was something that can sit on the cloud natively. It's something that can be resilient in the face of failure, and especially like Deepan was explaining, there are a lot of failures that will get you on the cloud. In terms of some specifics, we have thousands of servers in 2 AWS regions. We're in US and in Europe. And we have over 200 services in production for the short span of 2 years. The platform itself, this is pretty much how it looks like. Now, there is also a lot of information on this slide, and unfortunately, we don't really have time to go over it. What I want to do is basically tell you how it all fits together. This is a very logical view of the platform, and obviously, it all starts by our cloud provider and the services that we use there. Those are all the managed services that we basically pay for and use as they are. We focus on simple PaaS components, think DNS, auto-scaling, all those things, because they usually cater for 99% of our needs. And yeah, anything more fancy we build on top of that. This is how our infrastructure looks like, again, at a very high level. We have Cassandra, which is our main database driver. So we have Cassandra clusters that replicate data between regions. And we have hundreds of services. And all those services, they talk via RPC calls using protobufs via message bus. And on the very top, we have a proxy layer, which is like a smart router, if you want. It basically intercepts all user traffic. And at this layer, we can do all kinds of fancy things. We can shed traffic, we can shape traffic, we can augment, we can fail over between different regions. All the things that you would expect. Going a layer up, our orchestration layer, this is basically meant for server and workflow automation and discovery. This wasn't actually something we planned when we were building the platform. It kind of happened naturally because of the limitations that we experienced using cloud providers. The goal of those services is basically to facilitate any workflows that happen underneath, and they very nicely abstract all the cloud specifics to the rest of the platform. So those are the only services that are aware that we're actually running on the cloud. Anything beyond that is agnostic, and this gives us a lot of flexibility. It means that we can basically mix and match if we need to use different cloud provider services. And if we have to change something, the only thing we have to change is basically here. And just to give you an example of how this works, let's consider a simple workflow. Our platform is pretty much entirely event-driven. So each service is a client and a server, a publisher and a subscriber. And there is a lot of it going on. As we were building towards that, we realized that we are capturing all the events that we have in the platform, but we're not doing something very specifically. We are not capturing all the events that are happening on our cloud providers, for example. And there are also a lot of events that happen there, like auto-scaling, groups resizing, things going up and down, things change, are in flux constantly. And initially, we didn't react on that. We didn't even notice it. So to address this, we created a service that we call the Whisper service. And the role of the Whisper service, for example, is quite simple. It basically hooks to the event streams of AWS and sucks all the events it can and marshals them back to our own message stream, which in our case is NSQ. It's a message bus which is written in Go. It's quite minimalistic. And all our services connect to NSQ. They all know how to get information, how to marshal information from NSQ. So what this means is that when we have to basically add new event types or subscribe to other third parties, say, I don't know, GCE, the only thing we have to change again is the Whisper service. And yeah, those events will be magically available for everything else. We don't have to write drivers for those services to connect to the different event providers. It keeps everything pretty lean. Enough about that. Let's look at the core platform. This is basically the services that provide the pillars of our microservices ecosystem. They provide the most critical workflows, such as routing, service discovery, service provisioning, monitoring, configuration, all the things that you need to basically govern and manage the platform. And at the very top, we have basically hundreds of services that actually provide business value. Those are small, self-configured units of execution that just are wrapped around business capabilities or domain objects. And individually, they're quite simple, they're quite small, they don't really do too much. But together, when you combine them, they build very, very powerful workflows, and you can mix and match in very flexible ways. The aftermath of doing our exercise was, once we migrated our legacy infrastructure on top of the new platform, we got about 30% cost optimization, just because we were able to actually leverage better the cloud resources. And again, Diptano mentioned a lot of patterns for doing that at Netflix. We have some similarities there. It's all about being efficient and at the same time handling failure gracefully. We do dozens of deploys nowadays every day, compared to several bi-weekly that we used to have almost 2 years ago. And yeah, the most important thing for our business is we can actually execute in parallel. We can build business logic, features, products in parallel without having to spend too much time in cross-dependencies. Now, it's all pretty and nice, and we talked about how everything fits together. Now I want to show you a bit closer view of what actually a service is. In our world, a microservice is basically a set of self-configuring adapters and libraries and business logic. So as a developer, when you start a new project, what you get is a skeleton of a service which has pretty much everything there. It has smart libraries for doing service-to-service communication, for connecting to message buses, for connecting to things like Zookeeper. They all have like different failure scenarios in place, and you can like tweak and do whatever you want, but you get them for free. You get for free monitoring, you get for free instrumentation, you have all the hooks available for you. So what you can focus on is actually your business logic and basically wrapping up your domain and like database schemas if you need one. We have, as I said, hundreds of those guys, and yeah, together they can be quite powerful. This is not really good looking picture of the streams and the traffic that flows between our services. It's actually depicting only about 100 of them. It's a very old screenshot. If I actually show the real one, people get a bit put off microservices, so I tend not to do that. But yeah, the idea is that you combine those services and you can build very, very, very powerful interactions between them. So how do we stay on top of all this? I mean, microservices are nice. They can actually give you a lot of positive, especially to your business delivery, but they also present a lot of challenges. And to cope with that, we had to build a lot of tools. There are probably dozens and dozens and dozens of tools that we had to build that give you different insights, different view of the platform itself. They also give the business a lot of UIs, so they can understand how those services affect our KPIs or like tweak things. It's quite flexible, and we had to invest a lot of time of building both business-facing and developer-facing tools so that we can like govern everything. It all starts when it comes to deployment in production by having a way of deploying a new version of a service without breaking everything. And having, for example, a smart routing plane helps a lot, being able to deploy a new version of your service, send 5% of the traffic to it, see how it behaves, compare some graphs, see if it's actually doing what's supposed to be doing, and if it's as performant as the previous version, basically being able to see and spot problems early on. And if it's all good, you ramp it up, and at some point, yeah, you've deployed a new version of a service. On individual services, that works great. But as I said, in our world, a workflow is actually a bit more complex than that. So at Hailo, there is one KPI, one workflow that is more important than anything else. And this is, can we get people into a cab? If that works, it doesn't matter how many services have failed, It doesn't matter if we have degraded service. It doesn't matter anything, as long as we can get those people in. And this workflow is comprised by, I don't know, 5, 6, 7, 8 services. So the idea is that out of 200 services, if we lose 190, hopefully we should still be able to do that. And to measure it and to make sure that this is actually happening, we have an automated system that verifies that constantly in production. So the way it works is on one island called Kerguelen in the South Pacific Ocean, it generates custom driver, like robot drivers and robot customers, and these guys are like going and making rides constantly. As long as this succeeds, we know that it's all good. If it fails, well, there are problems. And for us, monitoring this critical path is the most important thing that we have to do. How do we know it hasn't changed? Well, the whole platform has been modeled, around run levels. Think Linux run levels, if you like. So each service gets a criticality and when it's supposed to be running. So with the press of a button, you can basically degrade and tear down the whole thing, meaning that if you say, I want only critical services to be running, everything else is shut down. And this is useful if you have a lot of back pressure or if you want to like test, as in our case, if your critical path is still your critical path. We have an environment where our automated system basically does exactly that every 5 minutes. So every 5 minutes it says, shut down everything else, leave only those services that have been marked as critical. If at that point our workflow succeeds within our SLAs, we know that the critical path is still valid and no one has introduced something that breaks it in some way. If that stops being the case, well, we alert. And by far, this is the only time that we send pager duties to our teams. This is the screen that we have in pretty much, the view that we have on every screen at Hailo. So what it shows you is the output of this automated system. There are two, the green and the red line, those are two streams, basically the success and the failure rate. As long as those streams don't cross, we're good. It's all good. If they do, we know we have a problem. And that's the only metric that really matters in production for our KPIs, for our business. On your right side, we have also an event stream of changes. So as people do deployments, change configs, anything significant happen, we measure that and we track that, and you can click and see exactly what happened, who initiated it, and what were the consequences. On the left side, you have another event stream, and this is about health checks. As a developer, you're responsible for defining what the health of your service actually means. And for some reason, if that's flagged, you can get your notification, or your team can get a notification. Because we have a very granular service-oriented architecture at Hailo, pretty much a developer might have 5, 6 services, so it's up to him to decide how he wants those services to behave when they are degraded. All those things are nice, but they're not the full picture. There is one component missing here, and this is actually testing features in production. Yes, you can deploy individual services and measure how they behave and see if they're doing the right thing. But if you actually want to measure a complete workflow that is actually the business value of the whole exercise, it's a bit harder than that. And to achieve it, we've been working hardly on something that we call service group memberships. The idea is very simple. It's all based on label-based routing. So the traffic that flows between the services, starting from the API all the way down, can be tagged. And our services can have labels as well, meaning that we can actually isolate the traffic that flows between them. And we can group services, making sure that any traffic that originates from them is basically held within this group. This is something which is pretty much transparent for the services themselves. It can be configured very dynamically. And you're guaranteed that any traffic that is being tagged will always prefer services that hold the same tag as well. The labels are always forwarded within the request context, meaning that if you have a longer chain of services in some workflow and you have to reach out for some functionality that you haven't put into the group, and if we consider this workflow here, you can ensure that on the code chain, the final recipient will still be a member of the group, and it will be the preferred recipient as opposed to some other service which is not a member of the group, and you're running, for example, multiple services, multiple versions of a service simultaneously. Memberships can be configured dynamically, and you can have as many groups as you want, different teams, different people. You can do all kinds of mixes and matches there, as long as we try to keep it on a single level. And yeah, it's a very flexible way of curating your traffic. I want to emphasize what this is and what the function is, because it's something which is very, very powerful, but at the same time very easy to abuse. And although we had this idea pretty much from the beginning, we took our time implementing it, not only because obviously it's not an easy thing to get to, but also because we felt that we need some maturity as an organization, as developers interacting with microservices before we actually use something as powerful as this. It is effectively a way of curating your traffic and testing complex workflows in production in isolation. It allows you to basically do high-velocity deployments and still achieve this isolation, making sure that your customers don't see a thing. You can think of it as an A/B testing of steroids if you want. And it's also a very powerful tool to have when things go wrong. And if you go and have more multi-tenant use cases, say you have people running software on your platform, things like that, this is also something very, very powerful. I also want to emphasize what this is not. And this is not something that allows you to basically build tightly coupled services, deploy them together, and build a big distributed monolith and hate your life afterwards. It's not supposed to be used for releasing backwards incompatible changes. You can get away with it, but this is not what you're supposed to be doing. And it's also not a replacement of feature flags, although, again, there are some use cases where it can be a very, very powerful tool in your keychain if you need to do something like this. And to wrap up, let's just finish with an example. Let's consider a very, very simple workflow. You basically want to see and get a driver that will take you home, and you want to see on your phone how quickly this driver will get to you. So in our imaginary use case, you probably are talking to some nearest driver service, which will talk to some index with all the drivers, that will find all the drivers that are around you, will offer them to get you home. One of them will accept. And once he does, what it will do is it will ask an ETA service how quickly this driver can get to you. Let's imagine here that the ETA service is pretty dumb. It just does straight line calculations about how you can get from A to B. And let's say that it can also rely on a traffic service which knows way more about the actual city, about how things work in the city, about traffic jams, about real traffic information. So it can give you a more accurate ETA if you want. In a setup like this, as the system evolves, you change different services, you increment the versions, it's all pretty much decoupled, so it all works. However, let's imagine that we wanted to introduce something big, helicopter. Basically, for our high flyers, we want to dispatch a helicopter that gets them and flies them somewhere, because it's all money, right? Surely some people can pay for this. So in a real use case, we'll probably write a bunch of services, and it will be a totally different workflow. But for the sake of this example, let's imagine that we want to modify those exact services and basically add the logic there. What we would have to do is probably would have to modify our nearest driver service to actually know that we can now search for pilots as well. Our driver index has to index those helicopters in their location constantly. And probably our traffic service needs to be aware of some, I don't know, air requirements, limitations, where can we dispatch those helicopters and where not, so someone doesn't shut them down. So all those things. If we're going to test this in production, once we actually deploy those services, yeah, we'll still deploy them individually. But at some point, we have to test if it all works well before we actually enable it for our customers. So what we would do is we'll basically put them in a blue group, in some feature group. So all those services will be tagged with a single tag, effectively. At that point, what we can do is we can grab a client and we can start sending tagged traffic, meaning that we'll only hit those services. All our existing customers, they will continue using the existing ones and they won't see a thing. While we will be able to see if our workflow actually works and actually does what we expect it to do. We can do better. Once we're happy with what's going on, we can select a group of our customers and enable that for them and see, is it everything working under load? Or, for example, how are they behaving with, like, how is the user experience with this new feature? Are they accepting it? Maybe they want something else, all those things. And even better, as we were rolling it out, we can have an experiment service which, for example, tracks what our users are doing, and it can identify, for example, potential customers for this new feature and enable it just for them. A lot of possibilities there, and it's all based on this simple logic. If we're modifying core services, our automated system can tag traffic as well and make sure that although you're releasing them in some like isolated groups, they actually still pass and they're actually doing what they're supposed to be doing. It's basically as simple as that. The reality, well, usually it's not 2-3 services. There are many services that participate on a code chain. One very important takeaway and something that is good to emphasize always is that those calls, although from a user perspective, it's one call and it can translate to many, many things happening in your microservices ecosystem, it's important to keep everything decoupled. And it's also very, very important to do things in parallel. All those things, they pretty much happen in parallel. And in this specific use case, if, I don't know, 7, 8 of those services don't return, we will still serve back success to our customer because it's more important for our customer to be able to get a cap than to tell him exactly that the cap will be there in 4 minutes. It might be there in 2, it might be there in 7, but if the service that is responsible for calculating the ETA is slow or unavailable, we should still be able to basically serve something. Thank you very much. It's been exciting. And now I would like to invite here on stage Fred, Tipano, and Sean to continue with the panel.